Hello friends, today in this video we'll see some of the applications of Ansys scripting. It uses Python script. Using it we can do a lot of things in Ansys. We can create a geometry, we can modify excitations, uh, we can generate a results. Uh, these are some of the we can assign meshes. There's a lot of what are the things you can do in Ansys environment. Using its which is shown on the Ansys GUI. Same thing you can implement using a Ansys script. And one of its use case that is to draw a geometry I have covered in the last video, which you can see on my channel. Today in this video, we'll see how to assign a voltage excitation to the transformer's winding. And we'll use script for this. There is one feature in Ansys record script to the file. uh, the things you do in a GUI, uh, this feature records it into the script, and that script you can use later on to implement the same thing. You can modify that script to tweak certain things in the model. It's a very handy feature, and it saves a lot of time, lot of headache. And if some repetitive work is there, it really simplifies it. So let's just start with it. So I have this transformer. You can see here the red winding is primary winding, and yellow winding is our secondary winding, and this is the core. And what I want to do with this transformer is this is basically an electrostatic simulation. You can see here. I want to measure the capacitances between the turns of the windings. So capacitance between uh, winding and core and between two windings, primary and secondary. In this video, I'll just show how to assign the voltages. Maybe in the next video, I'll cover how to build up entire model. Uh, so let's just start with it. Uh, I'll just flip the geometry. So here you can see there are 45 turns are in the primary and secondary winding. This is 1:1 transformer. And for the capacitance calculation, I have to assign the voltages uh, for each turn. So this is my first turn, and this is my 45th turn. And the entire voltage will get uniformly distributed across this all of these turns. So what I will do is apply 1 volt across this winding. So the 1 volt will get uniformly distributed across all the turns. And so in that way, I have to assign the excitation. Same thing I have to do with the secondary winding. And here you can see here V1 is defined as a 1 volt. I've used the V1 in my expression. So let's just start with it. We'll just start with assigning the voltage to this first winding. And let's go to assign excitation voltage. I'll name it as VP1, and value I will give as a 0.022. Why this value? I'll just show. If you so 1 volt we are distributing among a 45 turns. So the difference between the voltage, interturn voltage, it will be 0.0222. This is the voltage between two turns. And so the first turn will have 0.0222 volt. Next will have 0.0444. Then third turn will have into 3, which is 0.660666, like that. So this is the value 0.0222 into V1. V1 is the voltage. Right now we are giving 1 volt. We might give some other volt. So that's why we are defining this variable V1. Sorry, only. And for the V1, The unit is already defined, so I'm removing the unit. Okay, you can see here V1 is 1 volt. For V2, same way we have to do. Vp2 I will name V primary 2. And the voltage value will be 0.0444. Okay, similarly, uh, okay, sorry, I forgot one thing. We have to start recording the script. So that I have not done. So what I'll do, I'll just delete these two excitation because we have to first, because I am not going to assign the voltage to each winding manually. That will just take a lot of time. Also, I have to do the same thing for secondary. And you can see the voltage is gradually increasing. There is a in a linear way. So somehow I can use a scripting and make my life easier. So I'll just do that. I'll just say Ansys record script to file. I'll name it as assign excitation underscore 1 and save. Now again, we'll do the same exercise. Assign excitation, voltage, VP1, value will be 0.0222 into V1. Unit is already there. So same thing for C2. I'll name it as VP2 0.0444. Unit is already there. And same for C3. Assign excitation, voltage, VP3 0.06666 and unit is into V1. Don't forget to add V1. Let me check whether VP2 I have. We'll modify it in script, not an issue. So now just stop script recording and we'll open the script. Script is saved here in this folder. So assign excitation underscore 1. So this is the script you can see here. What we have done in the GUI, it has been recorded as a script. So it's a very important feature in the Ansys Maxwell. We can see C1 has been assigned with this voltage, C2 with this, C1 underscore 2 with this, C3 with this. What we have done in the GUI, same thing has been reflected here. So what we have to do here is, one more thing we forgot here that we'll just start. What I'll do, I'll just copy this. And what we can do is we can copy it 45 times and then we can just modify this C1 these objects, and same way we can get it done for 45 times, but that will also take a lot of time. Then what we can do, we can use a loops for this. We'll take a help of Chat GPT for this. If you are just starting with the GPT could be a great help for you. So we'll just use Chat GPT for this. We have copy pasted the script. What we'll say, we'll tell it to use loops to simplify the script. It has just used loops for it. But what it has done, it has just taken 3 objects and 3 voltages. Now we'll tell it use uh, object. We'll just tell objects ranges from C1 underscore 1 to C1 underscore 45. Okay, it has taken range from 1 to 46, voltage factor 0.02, and it has already taken this in the voltage factor it has taken, and accordingly voltage value it is giving. But this what it has used this F uh, double inverted comma. So that creates a problem when you are working with the Ansys. So I have faced this problem before. Instead of that, we can use a dot format. We'll just tell use dot format ins instead of F the comma. So it will just give it that. Hmm. Yes. And now it has created, right? So let's just try copying this code. I'll copy it. I'll create file, new file, Python module open. I'll just paste it. I'll save uh, the same uh, here. Assign excitation underscore one was our previous script. I'll just name it as assign underscore excitation two. This was our initial script. We have modified it as a like this way. So now just let's see what it does. Uh, I think it might create an issue because here you can see object range is taking from 1 to 46. Let's just see because we have just 45 terms. Let's just see whether it creates some issue. If it's creating, we'll just modify the script. Now we have to do what we can do is run script and we'll just run the script. First, we'll delete this our previous assignment because otherwise it will say VP1 is already defined. Now run script, assign underscore excitations to, there is some issue with it. Script environment is not defined. Okay, we have to start with this import script environment because the same script environment initialize it is using this script environment, but it is not defined here. So we have to start, every script should start with this line. Now let's just start again. Tools, run script, assign excitation underscore to open. Tada. It just started assigning the excitation. And it stopped till 45. It's just stopped at a right BP C1 underscore 45. Naming, it has done some mistake. Or it used some different terminology. That's just okay with us because that doesn't make any problem. Uh, and object name, what we can do is, yeah, voltage name. It is using object name inside it. What we can do, we can just use maybe I instead of that. Let's just try. First, we have to delete all these things. And you can see it like work like magic. Means all the 45 excitation it has done within a just like span of seconds. It would have taken you a half an hour just to assign it one by one, but it has done within just few seconds. That is the power of the scripting. And we have used Chat GPT along with it. So that's a good use case of AI, which can help you to boost the productivity, simplify your task. So these two tools are really helpful. Uh, Now we'll just make this change and see whether it reflects our change. Run script, assign underscore excitation underscore two, open and done. Yeah, that's it. You can see here VP1 it gave 0.022 V1, VP2 0.044 V1, VP3 0.066 V1, and in that way VP1 is 0.999 V1, which is almost V1. So entire V1 is uniformly distributed across the 40 pattern, and which we have done using a scripting. Uh, so that's a nice use case. Same way we can do for a secondary winding. I'll just copy this for loop and I'll just paste it here. Now our object name you can see here, it starts with a C2, C2 underscore 1, C2 underscore 2, C2 underscore 3 in that way. So we'll just modify this. We'll object name will define as C2 underscore and here that variable will come. It will vary from 1 to 45. And VP instead of VP, which is indicates primary, will just name it as a VS. And let's say I want along with the here what we were doing is we were uh, assigning as a let's say some factor into V1. In secondary, let's say I just want some factor into V1 plus VO2. Let's see whether it uh, implements that. You can see VO2 is defined here. Right now, the value is 0. It doesn't make any change in the value of voltage. But let's say if I give some other value to VO2, I want something else in place of VO2. It's 2 volt, 3 volts. We can do that. So I'll just add this variable here and let's start again. Um, let's first delete these voltages. And I will, whether the script is saved. Yeah, it is saved. Now let's run it again. Tools, run script, assign excitation underscore field. You can see here on the left side, all the excitations are completed. Till 45, we have verified already. You can see now VS1, which is 0.0222 into V1 plus VO2. This extra term we have added. VS2 is 0.0444 into V1 and VS45 will be 0.999 V1 plus VO2. See, total 90 excitation, it just did it within the span of seconds. And that's the power of scripting. You can use this, we have done for assigning excitation. You can do a lot of things with it. Let's say I have 1,000 turns in my winding. Then just assigning manually won't be possible. This will come as a great help. So one must learn how to script in Ansys. And with the use of Chat GPT, with this use of this feature record script, it's very easy. If you don't know anything about scripting, you can just start playing in the GUI window and just record it as a script. And later on, you can just go and check. Let's say this is our first script. You can just go and see if you do record multiple script. You can see these are the common factors will come at the start of every script. Here we are saying open the Ansys desktop. Here we are saying open this particular project. You can see the project name. Then we are telling him open this particular design. This things I have uh, uh, explained in my first video. You can go and check. These are some initial setup we have to do. Then you can see, oh, this function we have to use, which assigns the voltage, and we have to use it over and over. So we can use for loop here. So we just told to Chat GPT, just use for loop for us. Uh, let's make my life simpler, and it has done that. And maybe you have to do some certain modification, like I asked it to change, uh, use dot format instead of this, because maybe if you run this script you have some problem with that. And with some if you do some multiple scripting, you'll see this dot format. Chat GPT only, I learned this about this function dot format in Chat GPT itself, uh, and that I have been used in previous code, so I thought it might be useful here instead of this function, so I asked it to change. So with the with multiple practice, with the practice, you'll understand. And if you use it for other test cases, like drawing the geometry, assigning the meshes, creating the setup, creating the result files, you'll further will get more deeper understanding of this feature. So I'll encourage all of you to just use this very cool feature in the Answers. Along with the Chat GPT, it will make your life very easy. So that's it, guys, for today. Uh, in the next video, I'll take up this electrostatic design, how to create a model, uh, how to analyze this electrostatic model uh, from its creation to analyze to its analysis. We'll see in the next video, and we'll see how the electric field. Now we have given this excitation, how the electric fields comes with this excitation. Uh, that we'll see in the next video. Also, this model I have created using PMAG, that I want to take some tutorial on PMAG. In last video also I told about that. This PMAG is also a very powerful tool if you are into a transformer designing. And because if you start making these windings with your here, it will take a lot of time and it's difficult. The PMAG makes your life simpler for that. So basic model you can create using PMAG, and later you can make you can export it to Maxwell environment and just play with it and do a lot of more detailed analysis in Maxwell. I'll definitely take that in a future video. Um, so let's keep this video for just for the excitation only and the scripting. Later part we'll see in the next videos. Thanks a lot, guys. Hope you like this video, and see you in the next video.